In this paper, we investigate the motion in-betweening problem for two densely interacting characters. Given a set of predefined keyframes and reference input, our network synthesizes interactive and long-horizon in-between motions without quality degrading. Our system begins by taking a short motion sequence as input, represented in the coordinate space of the key pose. It then predicts a motion trajectory that minimizes the distance to the key pose. Next, we extract relative pose information between two characters, using it as conditioning interaction features. Our network then learns to adaptively modify the individual sequence and produce interaction. To enable long-horizon generation, we also propose an interaction discriminator and motion refiner. We encode the pairwise joint distance as periodic frequencies, and our interaction discriminator learns to distinguish between different pairwise joint distance patterns. Meanwhile, the motion refiner learns to restore the physical constraint and reduce pose error for each prediction, such that alleviate error accumulation and enhance long-horizon motion quality. The network is trained on a dataset where characters are performing dense and high-frequency boxing actions. We randomly sample 5 to 7 keyframes and produce motion sequences of approximately 8 to 10 seconds. Our system is capable of generating realistic, interactive, and long-horizon in-between motions without interaction quality degrading or pose deformation. We also test on RemoCap and interhuman datasets with dancing action. Our system is able to generate smooth and seamless turning motions in between the key poses. It can also generalize to Latin dance on interhuman dataset. In-between motions can be highly diverse. Therefore, we generate motions 3 times under the same input and key pose conditions. Our system is capable of producing a variety of motion sequences while maintaining high-quality interactions. The key pose are customizable by users. Here, we first demonstrate the first sample. Next, we present the second sample. Users are allowed to select, translate, or rotate the key pose of one or both characters. Our system then generates a new in-between sequence that adapts to the modified key pose. Try it again. Adjust the position and rotation based on the last key pose, and see how our system creates natural-looking interaction. In addition, users can modify the key pose as desired, and we demonstrate that the proposed system effectively adapts to user-customized key poses. We compare with a state-of-the-art interaction synthesis and a motion in-betweening approach. However, their method produced noticeable penetration or suffer from error accumulation. We also compare with phase betweener. To ensure a fair evaluation, we tested their approach under different setups, predicting motions for the two characters separately and as a single entity. Both way fails to capture interactions and presents wrong reactive motions. Cross-interaction attention occasionally produces penetrative motions and foot sliding. Cond MDI presents higher motion quality but unable to align well with the key pose. Phase betweener also produces penetrative motions. When feeding with two characters as a single entity, motion jitter occurs due to the exponentially increased complexity of the two-character state space, which makes the learning process significantly more challenging. Finally, we conduct ablation studies on the proposed module. First, we remove the interaction modeling of main network and only predict motions for two characters without exchanging relative pose information. Our interaction discriminator aims to enhance the interaction quality. Without this module, the quality of interactions diminishes after a few seconds. We have also developed a motion refiner to minimize pose errors and maintain physical joint constraints. While the network successfully recovers from noise in most cases, pose deformation can still occur, particularly over long horizons. Without an explicit interaction modeling, in-between transitions may not closely align with key pose. Hit reactions are generated even when there is no attack. Without discriminator, interaction quality quickly degrades after 2 or 3 keyframes. Without motion refiner, pose error could accumulate, result in motion jitter. It will also further introduce inaccurate features into the interaction modeling process, disrupting the overall interaction quality.